Good day, students. Welcome to my course. Today we'll work with tutorial 5, which is dedicated to spatial and attribute queries and making selections. So at first open the Word file, tutorial 5, spatial and attribute queries, and also open this ArcMap document, tutorial 5, and let's start our tutorial. At first we should repair our data. So you can do it with either repair data source, or you can click double times and see that in a source tab you can open here with a set data source, and let's find our map, soil point, right? Soil dots. Now, okay, so you can also link this dataset with the soil samples point vector you created in the previous model. So okay, and now our dataset is repaired, and let's also repair our streets dataset. So it's here, streets, and also soil map. And the last one is LULC vector. LULC vector. So, and select all features of dataset soil map which have an area that is larger than 100 square meters by using the query builder. Make sure that the method used is create a new selection and how many records are selected. So in this tutorial we will generally work with finding information in your spatial dataset. You can we will work on different types of queries, such as queries selections by attributes. When we search information in our attribute table, we'll work with a spatial selection when we give a spatial query without using attribute queries and attribute tables. And we will also work on definition queries, and we will also work with the raster queries, which differs from the vector types of queries. Generally, all types of queries here use the same language of SQL. So I think you a little bit familiar already with this language, but it's very simple how the query is made with the SQL language. So let's first start from our attribute queries. So let's open soil map here and see that we have the attribute here, area. We can use either this or this. I will delete this one because we created it before. So, and here we have attribute area, and now we should search polygons which have the area higher than bigger than 100 square meters. For this we click here, select by attributes, and we select from this area from this window area, and make it bigger than 100,000, right? So let's make a print screen here. So, and first we should verify even if the definition query is very simple. Try to always verify your query expression. The expression was successfully verified, the answer is so now we can apply here, and you can see here that 4 polygons have been selected, and we can close this one, and we can let's change the symbology. We can notify here that a certain polygons have been created. have been selected from 4 polygons have been selected out of 6, right, which has the area bigger than 100 square meters. So, and now we can close it and go to the other question. Select all features from that of dataset soilnet which have an area that is larger than 100 square meters and which are classified as alpha soils. How many records are selected? Clear the selected set of features, so none are selected. So now in this case, at first let's make a clear selection. When we make a clear selection, our definition, our query is deleted and we can start from the beginning. So now in this exercise we should write more complicated, more advanced SQL query expression with this select by attribute tool, because we need to select not just areas which polygons which are bigger than 100 square meters, but also which have an soil type of alpha soils. So here we need 2 attributes, area and soil name, right? So let's make expression here. Area is bigger than 100,000, right? And the second requirement is that soil name should be equal to, and here we can, after we click at soil name, we can get unique values and see which type of information this attribute contains. So we need alpha soils. So we make a print screen here and just verify the expression was successfully verified and apply. So only one polygon has been selected, this polygon, right? This polygon have been selected from our soil map. Let's snip it. And also the second type of method which we could use here. First, for instance, we made selection, right? Bigger than area, bigger than 100 meters, 100 square meters. Apply. And afterwards, we not deleting, so clearing selection, our selection. We could choose here a method, select from current selection, right? And we just clear here. So it's our select from our current selection. It's still our 4 polygons are selected, and afterwards we make a soil name equal to alpha soils. Apply. See the same result actually, right? So which method is more comfortable to you? It's your choice. I prefer to use more complicated, more complex queries rather than using we can choose here also accept select from current selection. We can create a new selection, add to current selection. We can also use this one and remove from add to current selection. When we choose, for instance, one polygon, right, we can choose additional polygons, writing here an expression. Also we can remove from current selection, right? So but this method is also useful, but I prefer to write more complicated query expressions. So the next question, write the query of exercise 1b down according to the formal structure of SQL. So SQL language is very simple. So it uses these 3 definitions. Select what you're going to select. In our case, we're selecting polygons, right? Because polygons are basic geometric objects in our case in soil map. From where we're selecting from, we're selecting polygons from soil map, right? Our data set, where and here we write expression, right? So where area is bigger than 100 square meters and the soil name is equal to alpha soils, right? Alpha soils. So see that SQL language is very simple. we select polygons from our soil map dataset, where, and here we write an expression